Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Physics 5054. This is Cambridge O Levels Physics, and today we have set our hearts to solve an alternative to practical paper. We call it ATP paper. We also call it paper 4. For this purpose, we have selected May-June 2010 4-2 paper. This paper 4 belongs from the Zone 2 or the Variant 2. In this video, we are going to present to you the solution of this paper. So the time allowed for this paper is 1 hour. So let's start this paper. So here we go. So here we have May-June 2010 4-2 paper. Okay, so the question number 1 is showing up on your screen. A group of students performs an experiment to investigate the flow of the oil at different temperatures. 200 centimeter cube of oil is heated gently and its temperature theta is recorded. The oil is then poured through a funnel into a second beaker as shown in the figure 1.1. So they have heated the oil and they have 200 centimeter cube of oil in this beaker, and when the temperature at a certain temperature, then they start pouring through this funnel, and they note down how much time it takes to pass the oil through this funnel. Okay, the time t taken for the oil to flow through the funnel is recorded with a stopwatch. State why it is important to stir the oil during the heating. So why we do the stirring during the heating? So that the heat is distributed uniformly throughout the body of the liquid of the oil, and the oil has uniform temperature throughout its body. To ensure that heating is done uniformly in the oil, the temperature is uniform in the body of the oil, throughout the body of the oil, you can say. B part explain why the oil is heated gently. You see, if you will heat you give excess amount of the heat to the oil will burn and it will become too hot. So oil is heated gently to prevent overheating of the oil. If sometimes the oil get fire also, okay? So, and it might start boiling also, okay? So the experiment is, let me show you my answer. Oil is heated gently. Okay, so let me have look at the marking scheme. He says temperatures increase is slowly, temperature changes, small heats up slowly, oil does not become too hot, prevent overheating, oil has low specific heat capacity, heats up quickly, oil has high boiling point, higher boiling point than water, above the 110 degrees centigrade, may break thermometer. Okay, so then we have, then he says here, we have the experiment is repeated for several values of the theta, means temperature, value of theta, and the t, the time for 200 centimeter cube of the oil to pass through that funnel are recorded in the table of the figure 1.2. So when the temperature is 69 degrees centigrade, the oil takes 13.69 seconds to flow through that funnel. And when the temperature is 52, it takes 14.97. When the temperature is 37, it takes 17.34 seconds. When the temperature is 24 degrees centigrade, it takes 21.16 seconds. When the temperature is 17 degrees centigrade, the oil takes 25.16 seconds to pass through that funnel. And when the temperature is 10 degrees centigrade, it takes 28.85. Okay. So on the figure 1.3, plot the graph of the t in the seconds on the y-axis. Here the time will be taken on the y-axis, and the temperature theta in degrees centigrades on the x-axis. Start your graph from theta 0 and the t12. Draw the curved line of the best fit. Okay, so here we have, you see, the time is here. Time is here, 12 seconds. It's starting from 12 seconds. And the temperature is here on, and it's a 4 marks question. And you know, the reading of your temperature is going from 10 to 69. And the reading of the time is going from 13.69 to 28.85. So this is our table. This is my x-axis. This is my y-axis. Okay. So x-axis is going from 10 to 69, and the y-axis is going from 13 to 28.85. Okay. So now you see I will 10, 20, 30, 40, 50, 60, 70. This is the temperature, degree centigrade, and it's going up to 80. And here we have the time, 12, 14, 16, 18, 20, 22, 24, 26, 28, and 30. So you can see here that we have labeled the diagrams. We have labeled the axis, sorry, and then we will plot those points. Okay. So we have plotted those points here. When the temperature is 10, the time is this much. When it's 20, and so here we have the table. Okay, so we plotted those points, and then I have drawn the curve of the best fit. You see, when I draw the curve of the best fit, I try to join maximum points, but the main thing is I draw a smooth curve. So here you can see 2 points are left, but this is my smooth curve. Hopefully you understand what we are doing here. And then we have, okay, estimate the time taken for the oil at 80 degrees centigrade to flow through the funnel. When the temperature is 80, so this much is the time. And I can show you, we can increase it. Okay. So when you see the temperature is 80, the time taken is, okay, it's 13 point something. It's 13.2. Yeah. So it takes 13.2 seconds. Then it says the maximum reading on a standard laboratory liquid in glass thermometer that is suitable for this experiment. The thermometers which we use in the lab, their maximum temperature is 110 degrees centigrade. 110 degrees centigrade. Their minimum temperature is the lowest temperature which they measure. That is, I think, you see the marking scheme? The minimum temperature they can measure is -10, and the maximum temperature they can measure is 110 most of the time. Explain why it is not possible to repeat a reading immediately after it taken. You see, we are pouring the oil at a certain temperature. So when you poured it, that oil, the temperature will drop. So you cannot immediately use that. You cannot immediately perform the same experiment with that oil. First, you will have to heat it again to the same temperature, and then you will be able to pour it. So because we are pouring the oil at a certain temperature, and we are noting down the time. So temperature of the oil has decreased. To reuse it, oil needs to be heated first to that temperature again. Okay. Okay. Then we have another. He says tick 2 boxes to show which of the following will make the experiment more accurate. Using a more sensitive thermometer, no. Using 2 people to take the measurements, that is can be a good idea. Using a thicker oil, no. Using a larger range of the readings. Pouring the oil quickly after taking its temperature, that is true. Okay. So these 2 things are good. Use 2 people to take the measurements, and pouring the oil quickly after the taking its temperature so that the temperature do not change. So here we have the marking scheme. Okay, so I'm going to the next question. That is question number 2. Here we have he says figure 2.1 shows this is question number 2. Okay, figure 2.1 shows a wooden meter rule with the small holes drilled through it. So here we have a hole, 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 here. Okay. So their question is the meter rule is suspended from the hole at the 5 centimeter mark. So from this hole through this pin, we suspended this, and then this will act like a pendulum and it can swing. The meter rule is suspended from the hole at the 5 centimeters, so it can swing freely as shown in the figure 2.2. The rule is made to swing from side to side, and time t, capital T, for one complete swing is determined. Describe 3 experiment techniques used to obtain an accurate value of the t. Okay. So if you want to find out the time period for the one swing, we do not measure the time directly. Okay. For one swing. What we do, we give it a jerk, and we apply force on it, and it starts swinging. When it has taken 2-3 swings. when it will be in the mean position, when it will be in the mean position, during the swing, when it will be in the mean position, you will start your stopwatch and then you will start counting. Okay. So you will count when it is on the mean position. You will start the stopwatch when it is on the mean position. And note down the time for the 20 swings. Or you can do for the 10 swings or 15 swings. Note the time for 20 swings. For example, 20 swings. Okay. Then divide that time with the 20. And you will get the time for one swing. Do it 2 times, 3 times, and then take the average for the time period. Another thing, very important. Uh, on the ground, when this scale is on the mean position, on the ground, put a additional mark. For example, with the spray, you can make a mark on the ground that this is the mean position of this ruler during its swings. So that will make your calculation much easier. It's a 3 marks question, sir. Here we have, it says, put a additional mark on the ground to show the mean position of the swing ruler. Start counting swings when it is on its mean position. Start the stopwatch as well. So you start the stopwatch when it is on the mean position and start counting the swings when it's on mean position. Time 20 swings. Divide this time by 20 to calculate the time for one swing. And then you can repeat this experiment 3 times and then you can take the average. Okay. So here question number 2, its marking scheme is showing up here. Okay. So you can pause the video if you want to read these answers. Okay. So we are going to the next question. And that's the B part of question number 2. The distance D between a hole and the zero end of the rule is varied by suspending the rule from different holes. The time T is determined for each value of the D. The results are recorded. This D is basically what? Okay, this D is when I will, here you see when I suspend it from this hole. Let me show you. Okay. Now, let me show you. First, you will hang it from this hole, then you will hang it from this hole, then you will hang the ruler for this hole, then you from this. So the distance above, that is the small d, this distance. If you hung it from this hole, then this will be the d. If you hung it from here, then this will be the d. Okay, I hope you understand. Okay, then we have that question. He says the distance d between a hole and the zero end of the rule is varied by suspending the rule from different holes. The time t is determined for each value of the d. The results are recorded in the table figure 2.3. When the d is 5, the time is 1.61 second. When the d is 10 centimeter, the time is 1.57. When the d is 20, the time is 1.52. When the d is 30, the time is 1.58. When the d is 40, the time is 1.91 seconds. Okay, describe how the t varies with the d. You see, when the d increased from 5 to 20, the value of the time has decreased from 1.61 to 1.52. When the d increased from 20 to 40, the time has increased from 1.52 to 1.91. This is, I am telling you from that graph table. Okay, so here we have, it says, so as the D increases from 5 centimeter to 20 centimeter, the T decreases from 1.61 seconds to 1.52 seconds. As the D increases from the 20 centimeter to 40 centimeter, the T increases 1.5 from 1.52 seconds to 1.91 seconds. Okay, then their question is, suggest the value of the T for D equals to 9.5 centimeter. So, here we have, you see, when you hung the rule with the 99.5, for example, let me show you. If this is 5, so you hung it from here, and this is 95. When you will hung it from 95, the rule will automatically become like this. So this will become 5. So 95D, it will have the same time period as the 5. So it will be 1.61. So 1.61 seconds. Okay. So right here 1.61. I have not written here 1.61. So it is 1.61 seconds. Okay. So then they say, so that's why T was not measured for D is equals to 50 seconds. If you will, you see, look at this diagram. This is that ruler, and this is 50 centimeter. That is the center of gravity. And here we have the hole. If you hung it with the nail through this hole, so when you will give it a little force, this ruler will not swing. It will start rotating. It will start rotating. Okay, because you now the nail is in its center of gravity. So if you apply force here, it will not swing. It will actually start rotating. When the rod is suspended from a hole at 50 centimeter from both ends, rod will not swing. It will start rotating. It will start rotating. Okay, this is my answer. Okay, here we have question number 3. He says the efficiency of a motor is measured using the apparatus shown in the figure 3.1. So here we have the load, here we have the string, here we have the pulley, here we have the motor, the power supply, and it's going to, we are going to lift this load up to a height of 1 meter. When the motor is switched on, the string winds around the pulley and the load is lifted. 6 students measure the time t taken for the load to be lifted a height h of 1 meter. The time recorded are 4.47 seconds, 4.53 seconds, 4.39 seconds, 4.44 seconds, 5.92 seconds, 4.61 seconds. The results of 5.92 second is discarded. So that's why this result is very much larger than the other. You see, this time this is different. This time is much more. So I think that that student stopped the stopwatch late, or maybe his stopwatch is faulty. That's why this reading we will not take, and this is not matching with the rest of the data. Okay, so the student stopped the stopwatch later. That is one reason which comes in into our mind. So then he says, calculate the average time t average for the other results. Consider the variation in the student's results. Give your answer to an appropriate number of significant figures. Show your walking. Okay, so we have to find out the average. Just add 1, 2, 3, 4, and 5. These 5 numbers and divide it with the 5. So you can see here, I have added them, and but then I've divided with the 5. You got 4.489. That is 4.488. Then when you round it off, it will be 4.49. That is the answer. That's the T average, 4.49. Okay. So then we have another question. He says, the efficiency of the motor is given by the relationship 2x post 2x per 2 and 3 multiplied T average. That's in the denominator. Just put the T average value here in this formula. You will get that value. So you can see here 2x per 2 divided by 3 divided by 4.49. That is 14.84%. 14.84% is our answer. 14.8 is the right answer, sir. So this is the right answer. Describe one way in which the student can measure age accurately. You see, how you can measure age accurately. You can place, you see, how you can do this. Uh-oh. So, okay. You can place a vertical scale here. Okay. And you can place here a set square to make sure that it's vertical. And you can place set square here to note down these are set squares, okay? This is how you will measure the height. Use a vertical scale. Use a set square to make sure vertical scale is vertical to the ground. Line of sight must be perpendicular to the 1 meter point on the scale to avoid the parallax error. Okay. That is our answer. I told you how this is. Okay. Okay. Then we have, he says, question number 4. A student performs an experiment using the optical pins to find the effect of a circular block made of the transparent plastic on the parallel rays of the light. The figure 4.1 shows the circular plastic block on a sheet of white paper. So here we have, let me show you that circular block. So they are talking about this circular block. Basically, they are talking about this. Okay. So figure 4.1 shows the circular plastic block on a sheet of white paper. The student draws around the block with a sharp pencil. And the student also draws 3 parallel lines up to the block before starting the experiment. Explain why the student draws around the block. So why we draw this? We mark the out boundary of that block so that by accident, if during the experiment, the block is displaced, the glass block is displaced, we can put it back on its original position. Okay, that is our answer. And that is why we put the boundary around that glass block. If the block gets displaced, it can be put back on its original position. Okay, so that it can be placed exactly. You can read this marking scheme. Okay, then we have, they say, then it says the student places pin P1 and P2 on the line 1, representing an incident ray of the light. Draw how the student places pin 3 and pin 4 to locate the emergent ray. Okay, so they are talking about this diagram. So on this line number 1, they have put a pin here, pin 1 and pin 2. Then he will go on the other side, on the opposite side where the pin 1 and pin 2 are, and he will look through this glass block. And when he see the image of the pin 1 and pin 2 through the glass block, he puts the pin 3 in such a way that the pin 3 and the image of the pin 1 and the pin 2, they are aligned. Then he put the pin 4 by looking into this glass. He puts the pin 4 in such a way that the pin 4, pin 3, and the image of the pin 2 and the pin 1, they are aligned with each other. There seems to be one. The pin 4 and pin 3 and the image of the pin 2 and the pin 1 in the glass, they appear to be aligned. By looking through the glass block from the opposite side where P1 and pin 2 is, pin 3 and pin 4 are placed such a way that they are aligned with the image of the pin 1 and the pin 2. That is my answer. Is the marking scheme. Okay. Then he says, okay. Describe how, okay. Then what you will do, then we will join these points, okay? We can join pin 4 and pin 3 up to the glass, and that will be the emergent ray, okay? On the figure 4 point, complete the path of the ray along the line and 1 through the block, okay? So first of all, join pin 4 and pin 3 up to this glass, and this is the incident ray, and you can see. So where the incident ray touched the glass and where this emergent ray touched the glass, join them with each other. And this is the path of the ray inside the glass block for the line 1. Draw the normal at the point where the ray along the line 1 enters the block. Okay. So here you have to draw a normal. So first of all, I will draw a tangent here. And then to that tangent, I will draw a normal. You can see this dotted line. This is the normal. Okay. First of all, I draw a tangent here. Then to that, I draw a normal. Normal is that is making 90-degree angle with that tangent at that point of the curve. Acha, measure the angle of incidence I where the ray along the line 1 enters the block. So if you want to measure the angle of incidence, this is the angle of incidence. Angle of incidence is the angle between the incident ray and the normal. That is the angle between the incident ray and the normal, and we have measured it, and that is approximately, I think, how much? That is 31 degrees centigrade. 31, sorry, I said degree centigrade, it's degree. Okay. Explain why a ray along the line 2 passes through the block without changing. You see, if you look at this diagram, the ray 2, the line 2, that is going undeflected. Why? Because it entered the glass block along the normal. When you enter along the normal into a surface, into a medium, your direction do not change. Okay, that's why. Incident rays along the normal, the surface, along the normal to the surface of the block, so the light do not deflect. Okay, along the normal. So it will pass through the center of the block. So on the figure 4.1, complete, he says on the figure 4.1, complete the path of the ray along the line 3. Okay, for the line 3, if you want to, so line 3 is this. Check how much is this distance, same distance, put a dot here. And check how much is this distance, same distance, put a mark here. Join this, then join this point. Okay, so this is how this is done. I hope you can see this and you can do this. Okay, so then we have, this is that diagram. Okay, so let me show you the diagram from here. So it's very small, because to show the whole diagram, I have to zoom out. Okay, so we are done with this question. This is question number 4. It's marking scheme. So, my dear students, in this video today we have done May-June 2010 Physics 5054 4-2 paper. This was an ATP paper. I have presented you the solution of this paper. I have tried my best to explain you the concepts and write the answers in such a way that you can understand them. If you find this video useful and interesting and helpful, please like this video. Also share the link of this video onto your Facebook, onto your Twitter account, onto your Instagram account. When you do this, this helps me to promote my channel. I think it's a great blessing for me that I can make these videos and touch the life of so many students around the globe. Thank you very much. Thank you very, very much for watching this video and taking our time. Have a good day. God bless you all.